Section 11.2, Picturing Data. Some types of graphs that can be used to display data are bar graphs, pie charts, histograms, frequency polygons, or time series graphs. Let's begin by looking at bar graphs and pie charts. So when data are representative of certain categories, rather than data being numerical, we often use bar graphs or circle graphs, commonly known as pie charts, to illustrate them. A bar graph is used to compare amounts or percentages using either vertical or horizontal bars of various lengths which correspond to the amounts or percents. A bar graph is used to compare parts to other parts. So you can look at individual bars on your graph and compare them to each other. Exercise 1. Suppose the frequency distribution below represents the responses of 100 people to the survey question, which grocery stores have you shopped at in the last month? Construct a bar graph for the data. Alright, so the stores we have are Stater Brothers, Trader Joe's, Vons, Winco, and Other. And 42 people said they shopped at Stater Brothers, 45 have shopped at Trader Joe's in the last month, 25 at Vons, 30 at Winco, and 75 at some other grocery store. So let's construct a bar graph for this data. On our x-axis or our horizontal axis, we can put down the names of the grocery stores. So maybe we have Stater Brothers, Trader Joe's, Vons, Winco, and Other. And our responses seem to go only up to 75. I think a good choice would be to break this up by tens. And our vertical axis are the number of people who said they shopped at that store. While our x-axis is the name of the grocery store. Now all we need to do is we need to draw corresponding vertical bars to match the height that goes with the frequency. So for Stater Brothers, 42 people said they shopped there in the last month. Trader Joe's had 45. Vons, only 25. Winco had 30. And for Other, we have 75. Oops, I should have made my vertical axis go up to 80. So for Other, we have 75. So by looking at our bar graph, we can get some information about how these different stores compare to each other. So we can see that the most frequented option was Other, which could be any sort of grocery store. Maybe it's Ralph's, Albertsons, Aldi, Food for Less. Then the second case that has the most responses would be Trader Joe's, followed by Stater Brothers, Winco, and then Vons. So by comparing parts to parts, we can at least see which response had the most, which was some other grocery store. And we can also see which grocery store was shopped at the least out of the options, which was Vons. So it just gives us a pretty quick visual representation of parts to parts, so comparing the number of shoppers at the grocery stores. Notice that in the exercise we just completed, our categories overlap. So there were 100 people surveyed, but our categories add up to more than 100. right? If we look back, if I just add even the first 3 categories, I have 112 responses already, and I only asked 100 people. So what that means is some people said that they shopped at more than one of these stores. So our categories are overlapped with each other. This is a good reason to use a bar graph rather than a circle graph, because as we stated earlier, a bar graph compares parts to parts and not parts to the whole. And I can't compare to the whole here when my categories are overlapped with each other and some people gave responses that went into more than one category. In a pie chart, we can compare parts to the whole. A pie chart is just a circle that is divided into sections in proportion to the frequencies corresponding to the categories. So again, a pie chart still represents categorical data like a bar graph does. And it shows the relationship this time of parts to the whole. For example, problem 2, we have the frequency distribution below represents the responses to the survey question, how often do you bring your own bags when grocery shopping? And we want to draw a pie chart to represent this data. Now these categories aren't going to overlap. You either answer that you always bring them, you never bring them, you frequently bring them, or you occasionally bring them. So what we should do is we should first figure out how many people were surveyed. So let's add up all of our responses. And conveniently, this adds up to 100. And the reason I say this is convenient is because one way that you can break up your circle is to think of it as the whole thing being 100%, and I can turn all of my responses into a percentage out of the entire circle. Well, if my entire circle is out of 100, then when I look at my first category, which was always, and 10 people said they always bring their reusable bags, that's 10 out of 100. And we know that if you want to write a percent, you can literally just write it over 100. So this is the same as 10%. Or you could divide this in a calculator and get back the same answer. So for my always, we have 10%. For never, we had 39 out of 100, or 39%. Frequently was 19 out of 100, which is 19%. And occasionally is 32 out of 100, or 32%. So what we want to do is we want to break up our pie chart into these percentages. So looking at this circle, we could divide it into quadrants if we wanted to see like where the 25% marks are. Okay, it's not perfect, but here is the circle kind of divided into fourths to help us get an outline for where we should cut off our percentages. So the first one we have 10%. Now this first quadrant here is 25% of our graph. So half of it, if I drew a line here, would be 12.5%. So I need a little bit less than half. Okay, so we'll let this little wedge be our always response. Now let's graph never, which is 39%. So what's left here, if this was 25%, means I have 15% left in this little piece. And then I need 24% more, which is almost this entire sector right here. It's just 1 degree less. So I'm just going to draw a line really, really, really close to this line because I need to get rid of 1% of that corner there, or that bottom quadrant. Okay, in this section here, it's going to be our 39%, which represents our never category. The next one we have is frequently, which is 19%. I have 1% left between this dashed line and the blue line I drew. And then this sector here is 25%. So I need 18% of this wedge. And that's going to give us this piece here, which is our 19% for our frequently. And this leaves the remaining 32%, right? This piece here is 6%. And this leaves the remaining 32%, right? This was 1%, so this is only 18% of this bottom quadrant, which out of the 25 means I left 7, and 7 plus 25 does give us that 32. And then I'm just going to remove the dotted lines that I put in as a guide. And I'm left with this pie chart, and you could color it in if you wanted to. And you don't have to fill it in with color, but if you do, it just kind of makes the wedges of your circle stand out a little bit more. And now it's easy to compare parts to the whole. So I can see if the whole circle makes up all of my responses, 10% of my responses were for always. 39% of my responses were for never. Or out of all my responses, most people replied with never. Or 32 of my 100 responses were occasionally. And it's just a nice visual of how the breakdown of your responses would look. Now, I mentioned that we were really fortunate that our distribution added up to 100. And the reason why we were so lucky to have that is because it made our percentages very easy to calculate. However, regardless of what your distribution totals to, you can still determine your percentages by just dividing the amount in the category by the total amount. So let's say if our last problem was only out of 98, and in my first category I had 10 responses, I would have done 10 divided by 98 instead of 10 divided by 100. Now there is another method for setting up your pie chart, and it's to use degrees. So determine the degrees for each slice of the circle. Now a circle is made up of 360 degrees. So what we can utilize in our degree formula is if we divide the frequency by the total number, or like the number of responses for one category divided by the total number of responses, and then multiply it by 360 degrees, it'll tell us how many degrees of our circle make up that portion of our slice. So let's try the exact same problem again using degrees. Well, according to our formula, to find the degree, you need to do the frequency, which for our first category is 10, divided by the total, which remember this adds up to 100, multiplied by 360. I'm going to simplify a little bit before I start, so I'm going to get rid of the 0 here. And notice both of these also end in 0, so I'm really just left with 36 degrees. Let's do this for the never category. So I have 39 out of 100 times 360. Again, I can eliminate one of the zeros. So I really need to do 39 times 36 divided by 10, which is 140.4 degrees. For frequently, I have 19 divided by 100 times 360. Plugging this into your calculator, you'll get 68.4 degrees. And the last category, 32 divided by 100 times 360, is 115.2 degrees. So just like we did above, we can break our circle into quadrants to kind of help with figuring out how many degrees we're looking at. So if you want, you can divide it into 4 again. And now, rather than thinking of each of these sections as 25%, we're going to think of them as 90 degrees, because the entire circle should add up to 360 degrees. So that's just 90 plus 90 plus 90 plus 90. So think of each of these quadrants as having 90 degrees of the circle, and we want to break this up into wedges matching the degrees we found below, which is 36, 140.4, 68.4, and 115.2. If this top quadrant is 90 degrees and I want to do 36 degrees, well, half of 90 would be 45, so it's a little less than half of this quadrant. So we'll let this be our 36 degrees of our circle, which stands for always. After that, we have our never category, which is 140.4 degrees. Well, if that top quadrant is worth 90 and we just took away 36 of it, then I have 54 degrees left here. And this quadrant is equal to 90. So in total, from this blue line all the way to halfway throughout the circle, I have 144 degrees left. So it's almost 4 degrees too much. So I need to cut it off, leaving 3.6 degrees left. So we'll say roughly from here to here. So this represents 140.4 degrees, which is our never category. Our next one ended up being 68.4 degrees. Again, this section is 90. I have 3.6 left here. So let's do 68.4 minus 3.6, which means I need 64.8 of this circle. Half of it's 45, so a little more than half, maybe somewhere over here. And this wedge here represents our 68.4 degrees, which is our frequently category. And this leaves 90 degrees plus this leftover section, 25.2 degrees. And 25.2 plus the remaining 90 does equal that 115.2. So this last section up to this dashed line is going to be our occasionally category. Again, I'm going to remove the dashed lines that we put in for reference. And now that we've removed those lines, it looks exactly like the graph we did the first time, just not colored in. Let me color it in. And now that it's filled in, hopefully looks just like the one we did when we first did problem 2 using percentages. Histograms and frequency polygons. When data are organized into grouped frequency distributions, so when we have numerical data, two types of graphs are commonly used to represent them, and they are histograms and frequency polygons. A histogram is similar to a vertical bar graph in that the heights of the bars correspond to frequencies. The difference is that class limits are placed on the horizontal axis rather than the categories. So for exercise 3, let's refer back to section 1 when we talked about record high temperatures for the 50 states. We created a grouped frequency distribution in that problem. We want to use that to draw ourselves a histogram. We're going to write a scale for the frequencies on the vertical axis, starting at 0, so making sure we cover all the way up to our highest number. And we're going to write the class limits on the horizontal axis. And we're going to end up using the lower class limits. So here's our frequency distribution that we made last time we saw this data. We said that in the vertical axis, or on the vertical axis, we were going to list our frequencies. So our frequencies seem to go from 1 to 16. We want to start at 0, so let's make sure we go at least up to 16. I'm going to go by 2s. And if you remember, these frequencies, or these number of responses, stood for the number of states with a temperature in that category. So these frequencies are the number of states. Across the horizontal axis, we're going to put our lower class limits. So our lower class limits are 100, 105, 110, all the way up to 130. But we're actually going to go back one class and forward one class as well. So if I had a class before this 100 to 104, it would have been from 95 to 99. So for my 0 here, I'm going to start at 95. Then I'm going to jump to my lower class limits 100, 105, 110, 115, 120, 125, 130, and I want to go one class further, so if I had another class after this, it would be from 135 to 139, so my lower class limit is 135. Now we just need to draw vertical bars like we did on the bar graph, where the height of the bar represents the frequency for that class. So for the class 100 to 104, I had 3 states that recorded a temperature within that range. The class 105 to 109, we had 8 classes. The class 110 to 114 had 16. And this would be your frequency polygon. So again, it looks very much like a bar graph. However, it's the one we used for grouped frequency distribution or numerical data. A frequency polygon is similar to a histogram, but instead of bars, a series of line segments is drawn connecting the midpoints of the classes. So we need to calculate the midpoints. The heights of the points that we plot should match the heights of the bars we drew in our histogram. So for exercise 4, let's make a frequency polygon for the same data set that we just drew the histogram for. So this is the data of the 50 states' highest recorded temperatures. We want to write the scale for the frequencies on the vertical axis and label a scale on the horizontal axis with the midpoints. These are the midpoints of your classes. Let's find the midpoints for each of our classes. So our first class goes from 100 to 104. To find the midpoint, you just need to add the lower class limit with the upper class limit and then divide by 2, because that should give you the average of these two numbers. And if you do that, you'll get back 102. So our midpoint of our first class is going to be 102. For our second class, we have 105 plus 109. Again, when you get that, divide it by 2, and you'll get back that the midpoint is 107. And you might actually be able to look at these and just see what the point in the middle would be, but sometimes your numbers won't be as nice as these, and it'll be a little bit more difficult to just notice. So it is good to practice the math behind it. So take a second on your own and pause the video and calculate the remaining 5 midpoints. And these are the midpoints you should have gotten. So 102, 107, 112, 117, 122, 127, and 132. Let's go down to our graph. In the vertical direction, we said we would list the frequencies, which again go from 0 to 16. So I'm going to go by 2. And this frequency represents the number of states with recorded temperatures in that class. And on our horizontal axis, we're going to put down our class midpoints. Now, similarly to last time, we want to start as if we had one class prior. Maybe you noticed while you were calculating these that they were each being increased by 5, which is our class width. So if I just subtract 5 from this midpoint, I would find that if there were a class before this, the midpoint would have been 97. And then let me list the midpoints that we found. And if there was a class after our last class, the midpoint would have been 137. So now our first one starts at 0 because that's the class we don't have. For the class of 102, that was our first category, has a frequency of 3. You put a dot above the midpoint at 3. The next class had a frequency of 8. Our third class has a frequency of 16. Our fourth class has a frequency of 13. Our fifth class has a frequency of 7. The next class has a frequency of 2, frequency of 1, and then in the class after that we have 0. And now what you want to do is you want to go back and connect all of these dots with line segments. And this is our frequency polygon for our data. Now notice if I go back to the histogram that we drew, and I put a dot at the top of the bar in between the classes, if I were to connect all of these dots, it would give you back the frequency polygon that we just drew. So you can see that these graphs are very similar, just a slightly different representation. One uses bars and the class limits, and one uses lines and the midpoint. Time series graphs. A time series graph can be drawn for data collected over a period of time. This type of graph is used primarily to show trends, like prices rising or falling for the time period. Some types of trends we have are secular trends, which are viewed over a long period of time, such as yearly. Cyclical trends show oscillating patterns, and seasonal trends, which show the value of a commodity for shorter periods of the year, such as fall, winter, spring, and summer. Exercise 5. The data represents the number of iPads in millions sold by Apple from 2011 to 2018. When we're doing our time series graph here, we want to label our horizontal axis with the year and the vertical axis with the number of iPads. So we want to plot points and then connect them with line segments. So across the bottom we have our years, which start at 2011 up through 2018. And make sure to label your horizontal axis. Our vertical axis will be the number of iPads in millions. Well, it seems to range from roughly 30 to 71. So I'm going to go by tens up to 80. And remember that these represent the number of iPads in millions. In the year 2011, they sold 32.47 million iPads. Let's say roughly here. 2012, it went up to 58.14, so almost 60. 2013, 71.76. 2014, 67.99. 2015, 53.85. 2016, 45.59. 2017, 43.73. And 2018, 43.5. Connect these with line segments. And we should get back something close to this. And from this graph, we can kind of talk about some trends that may be happening. So it seems like when the iPads were first coming out, there was a big spike in sales, probably because no one had an iPad, right? So it was really exciting to go out and buy one. So for the first few years, sales definitely were increasing because lots of people were purchasing these iPads. But then it seems like over time, right, our sales seem to decrease, which could be due to a lot of factors, but maybe it's because people already had iPads, so there wasn't as much of a demand. Or, if your iPad is still working, you may not just buy the newest model just because it's new. You may not upgrade for quite a few years. So I think that's why they're still selling many, many iPads up till 2018, but not quite as much as when it first came out and was really popular.